taking a look at some problems from section 1.5, picking it up at number 4. I'm going to set this up and you should be able to do the work. Problem is setting it up. Morse is designing a new sign for his ice cream shop to be placed at the exit of a highway. In the world of word problems, that means absolutely nothing. The sign needs to be big, really big. Good, still a lot of fluff. And you notice I'm just crossing all that out. He plans on making the height of the bottom triangle 3 times the height of the semicircle on the top. All right, so I have this distance up here. From there to there, what would you like? What do you want to call that? We don't know, right? So what do you want to call it? What's the most popular unknown?
X.
X, yeah. So we're going to call this guy right here X, which means this guy, the height of the ice cream cone, should be how much?
3x.
3x. Excellent. Okay, so he plans on making the height of the bottom triangle 3 times the height of the semicircle on the top with a total area of 74 square feet. So I need 2 things. The area of the semicircle plus the area of the triangle, and that has to equal 74 square feet. If the county will not allow the signage taller than 15 feet, will Morse be able to put this up? All right, so I need to find the area of the semicircle. Well, that's going to be 1/2 the area of a circle, right? So the area of a circle is what? Area of a circle. I'm not giving you this one.
Pi r squared.
Pi r squared, right? And here we go. Instead of pi, we're using 3.14. R is the radius. That just happens to be x squared, plus 1/2 the area of the triangle. Or excuse me, the area of the triangle. What's the area of the triangle? 1/2 the base. How far across is that? Well, if this is x, it's like our radius. So that means this has to be x, and this has to be x. X and x, 1 banana, and 1 banana is 2 bananas. 1/2 the base times the height. Now it looks kind of doable, right? I see x squareds. You know, this is the section with quadratics. I should be able to go through and calculate that. Shoo-doo-doo-doo-doo. Okay, we're going to put a hold on that right now. I'm going to come down here to number 5. Quilters can create an astonishing variety of patterns using geometric shapes. The card trick quilt pattern is built from squares, half triangles, and quarter triangles. Well, that's kind of crazy looking over there, but I believe all that. The finished pattern looks like overlapping cards. Yeah, that's kind of cool. If each square measures 3 by 3 inches, so each one of these squares is 3 by 3, okay? What is the length of the full diagonal of the 9 square pattern? All right, so the diagonal, if I remember correctly, goes something like that. And the diagonal is what we've just been working with. You know, we're doing, I'm doing trig stuff. Well, this comes from the Pythagorean theorem. This comes from the Pythagorean theorem. How far, how long is it across this bottom?
Would it be 9 because it's 3 times?
Exactly. How far up am I going?
9.
9 as well. And I know this is a right triangle, so I bring into play the Pythagorean theorem. Leg 1 squared plus leg 2 squared equals this diagonal square, we'll call it D, equals D squared. That goes back to the section where we were looking at problems that didn't have that X term. It only had the squared term and the constant. Questions on that? Okay, Anne Marie is looking to build a quilt from a 9 square card trick blocks. That's those bad boys. The quilt will be 2 blocks wide. So my quilt is going to be 2 blocks wide. And if it's a 9, so how far across is the quilt? Two times 9. It's a 9-inch square block. We're going to use 2 blocks. Answer is
18 inches.
18 by 3 blocks long. 27.
27.
Yep. They want to do this and then have a border size of X all the way around. So you can see this border going around to make it of size X. So how much farther out on each side am I going? Well, I'm going to go out X. We saw a problem similar to this a little while ago to give me this new one with the border. Okay, so Anne Marie's quilt measures 682 square inches. 682 square. So if I want to find the dimensions of this, I know it has to equal 682 square inches. How far across is this right now? Well, here's an X, there's 18, and there's an X. What's X plus X?
2x.
2X, and then plus that original 18. The next one is going to be
2x plus 27.
X plus 27. Good. Okay, this is almost the 0 product property, but I don't have a 0 there. So I'm going to have to multiply everything together, bring the 682 over, and go from there. So now I'm going to put you back in your groups, and I'm going to have you finish out these problems. So I'm going to pause the recording. All right. So I do know 2 of the groups didn't say much of anything to each other, and the other 2 groups were actually having conversation. So that's kind of a good thing. I did the work, and I end up with square root of 16, which is 4. If I plug 4 in, I have a height of 4 for that semicircle, a height of 12 for the bottom part of the ice cream cone, which is 16, and it's no, the sign's going to be too big. Anybody else get something similar to that? I'm just going to start calling random people.
Yeah, I got 16.19.
Good. Questions? The next one was you had this diagonal. We had 9 squared plus 9 squared equaled X squared. 81 and 81 is 162. If I take the square root of 162, Google told me that it was 12.7. So the diagonal on this square shape was 12.7. Anybody have a chance to get that far?
I did. Yeah, I got that.
Good, good. Yeah, they're easy once the problem's set up now, right? Because we've been practicing all these other steps over and over. And again, the more word problems you do, the better at those you'll get as well. Ba-da-ba-da-ba-da. Okay, Anne Marie. Anne Marie is making the quilt. We set this up as, instead of being 18 by 27, she's going to add a certain amount on both sides so that it can become an area of 682. Actually have to break out the old calculator a little bit on this one. subtract the 682 from both sides. And one of the things I know I can do before I factor is divide everything by 2. Still have my hands full with trying to factor this one. Could you use completing the square? You could. Could you use factoring? Sure, that's what's done here. Could you have used negative b plus or minus the square root of b squared minus 4ac all over 2? Yeah. Well, we end up with 2 answers. A negative, which we know it can't be, and a positive, 2, which it can be. So we would be adding 2 onto both sides. Cool. Okay. Let's move on. I'm going to keep going unless you folks have questions and kind of ask me to slow down a little bit. But I think this is one y'all can do because the formula is given to you. The average weekly earnings in dollars for a group of workers can be approximated by that, where X represents the number of years since 2004. Or blah, 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 blah. What this really means is somebody took a graph and across the bottom, they were doing years from 2004. And, you know, 2005, 2006, 2007, and so on. And what they did was they plotted these dollars of what people were making. So they had all these points, and all of a sudden you say, hey, that almost looks like a quadratic shape. Okay, I'm making all this up. Don't say, where'd you get all that? Don't panic. I'm making this up. And then he said, wait, this looks like a quadratic happening. So with the help of a calculator or a computer, they were able to come up with this equation that says everybody's kind of close to this line. And that's where a lot of this math comes from. You know, you start with a bunch of data and all of a sudden you get a shape and you get an equation for that shape. You do what's called a regression and it gives you an equation. Okay, so let's see what's going on. This is the year in dollars from at 2004. So determine the average weekly earnings in 2007, which is 3 years later. So E stands for earnings. I don't know why they have X. They should call it Y for years because this is years. So really they should almost have a sign. X equals years since 2004, because somebody might be tempted to put 2007 in there. So we need to put in the years since 0.12 times 3 squared plus 7.8 times 3 plus 555. Get an answer of that's a little calculator work.
$579.48.
Excellent. $579.48 a week. Some of you are going, what? I know, right? That's about $15 an hour. That's also back in 2007. I just divided this by 40. I made it like $60, 600 divided by 4, $15 an hour. But back in 2007, that wasn't bad. In what year? So now, in what year, X deals with my year, did it reach 638? So I'm going to do a little bit of an opposite here. 638 equals 0.12 times X squared, and X is the years since 2004, plus 7.8 times X plus 555. subtract 0 equals 0.12x squared plus 7.8x plus 555 minus 638 looks like it's going to be a negative 83. Hey. Not all problems are cute and pretty, by the way, as you can clearly see. Now I have to figure out how to factor solve. That looks like a mess. So I'm going to do this. X equals negative b, negative 7.8 plus or minus the square root of b squared, 7.8, minus 4 times a times c, all over 2 times a. Now I have to do some calculator punching. Negative 7.8 plus or minus the square root of 100.68 all over 0.24. And I'm going to let the rest of the work up to you. You should get one of your answers is x equals 9.3, which means the year would be 2013. One more. One more. Try to keep that up there still so some of you are copying. Unless I get a hold on. Anybody need 30 seconds? Okay, we'll keep going. If an object has an initial vertical position, woohoo, an initial vertical position and an initial velocity and where acceleration is at, okay, I think I got this now. And an arrow is shot 6 feet upwards. So I'm at 6 feet and I have an arrow going up to a certain height and coming all the way back down to the ground. And the path of this arrow, again, it's that U shape, so it's a quadratic, is going to be given by this fella right here, where I have S is a height. So the initial height is 6. That means it's going to turn that S sub 0 into 6. So this is my height. My initial height is 6. All right, so it's shot upwards. Okay, this isn't too bad. G equals 32 feet per second. All right, so negative 1/2 times G, which is 32 feet per second. I have T squared. Okay, and then I have, what is V sub 0? Well, V is this velocity, and I look down here and I see, yeah, this is a tough problem the first time you do one of these. This 32 deals with gravity. So if you take a physics class or something, you may have seen that 32 feet per second kind of deal. So I've now come up with an equation that's going to model in terms of time, how far up in the air this arrow is. So if time is 0, that whole thing becomes 0. This whole thing becomes 0, and you can see its height is 6. So I have a couple of things going on. When is it going to reach its maximum height? When is it going to hit the ground again? So I have a couple different things going on that I could ask about it. But that's my equation from all of that. So you're going to be in a physics class and they're going to help you set this up. You know, they'll give you the G and they'll give you the V sub 0, which is the velocity. How fast is that arrow going when I shoot it? And they'll give you the height. So now I have one more part of this that says, how long will it take the arrow to land? Well, if the arrow lands, that means this height, well, that means this height has to be 0. That's going to be over here. So this guy is the height. This guy is the time. Negative 1/2 of 32 is negative 16t squared. Something I saw a little while ago, I can divide everything on both sides by 2. 0 equals negative 8t squared plus 10t plus 6, oh, excuse me, plus 3. You almost did it. Plus 3. Now I would have to factor that, see what I come up with. I don't like that negative there. Does anybody else? Am I allowed to multiply everything on both sides by -1? The answer is yes. As long as what thou doest to one side of an equation, thou doest to the other side of an equation. So now I'm going to factor. If I get lucky, I'm going to try trial and error with this one. Eight t squared minus 12 plus 2 is -10. Woohoo! This time's going to give me -1/4. That's no good. This time, 2t minus 3 equals 0. Add 3, divide by 2. 2 equals 3/2 of a second. 3 1/2. 3/2 seconds, which is 1.5 seconds. So 1001, it lands back down on the ground. Hopefully you can get the heck out of the way before then. Okay, any questions? All righty, so that'll put 1.5 to rest. Do, 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 do. Do, 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 do. 8 o'clock's a tough crowd. Right, Nina, give me a thumbs up. Okay, cool. Jesse gave me a thumbs up. That's good. Jandy out. Jandy, are you here? Jandy didn't go into the last breakout room, so I know she's not around. All right, so we're starting to get a little conversation in the breakout rooms. So I'm going to do a couple of these, maybe give you a couple of them, but this guy over here, we're going to skip him. He's the difference of cubes, and I don't think in college algebra difference of cubes is needed because you don't need it till calc and you forget how to do it anyhow. So it's one of those in time things, not something that I want you to have to learn now. So difference of perfect cubes are a no-no. But what about this guy? 8x cubed. 8x cubed plus 4x squared minus 5x minus. Any of you remember from your last math class, what do I do when I have 4 terms? What was the way to solve this? G word. Starts with the G, ends with the G.
Grouping.
Grouping, yeah, excellent grouping. And grouping said, let's take these 2 terms and then these 2 terms and group them together. Grouping. I'm going to make a note on my notes. I'm going to use something called grouping. All right. If I look at the first 2, I group them together. I'm going to factor something out. What can I factor out?
4x squared.
Excellent. 4x squared. And I'm left with
2x plus 1.
2x plus 1. Now, this guy being a cubic tells me there better be 3 answers. Okay. I'm going to do the same thing, but I know when I pull something out, I need to be left with 2x plus 1. And that's not too bad because I can pull out a negative 25 and I'm left with 2x plus 1. Ooh. I can think of this as one thing and this is one thing. One term, I can pull out the 2x plus 1. And out of this one, I'm left with the 4x squared. If I pull the 2x plus 1 out of here, I'm left with the minus 25. Yay. I now have the 0 product property. 2x plus 1 equals 0. 4x squared minus 25 equals 0. I'll do this one. X equals negative 1/2. I can factor this because I know that this is the difference of perfect squares. It becomes 2x minus 5, 2x plus 5. Difference of perfect squares becomes the product of a sum and a difference. Oh, I think I had that in another course. The difference of perfect squares becomes the product of the sum and a difference. Nice. X equals 5/2, negative 5/2. Cool beans. Y'all get the same answer? Yeah. Okay, good. Another crazy equation. Ooh. Before I do number 3, I'm going to make a note to myself. X cannot equal what? What
0.
can equal 0.
Oh, it can't equal 1.
Correct. Or
Negative 1.
good. And the reason I'm not
You
allowed.
can't have 0 in the denominator.
Excellent. I'm not allowed to divide by 0. The world goes to if I try to divide by 0. All right, so now I have this, oh boy, I have this 1 over x minus 1 minus 2 over x plus 1 equals 2 over x plus 1. I want to clear the denominators. I want to clear the denominators. So that means I'm going to multiply everything on both sides by something. And when I do it on the left side, I'm going to have to distribute. So I need to multiply by something that's going to clear my denominators. Has a name, you'll forget. I just want you to remember how to do it. It would be the common denominator. Does anybody know what I'd like to multiply by? Well, I'd like to multiply by an x plus 1, right? That'll get rid of that. What thou doest to one side of an equation, thou doest to another. That would help me there. But what's the other thing I need to multiply by?
Negative 1 or x minus 1.
Excellent. X minus 1. And again, if I'm doing it to the left side, I have to do it to the right side. All right, so this first time I'm really going to write it out. I'm going to distribute, blah, blah, distribute. I don't know why I turned into a Viking there for a second, or not a Viking, a vampire. So when I do it, I'm going to get x plus 1, x minus 1 over x minus 1 minus 2 times x plus 1, x minus 1 over x plus 1 minus 2 times x plus.